I want you to watch this very carefully. In this video, nothing crashes, no red errors, no containers down, no alerts firing, and still this system will fail its users quietly. That's the most dangerous kind of production failure. This is not a Kubernetes tutorial, and this is not a clean demo. What you are about to watch is how most real production systems actually start. One API, one worker, one database, one queue. Everything in Docker Compose. And for a while, it works until it doesn't. Let's build something that breaks. Quick pause. If you want to learn DevOps the way it actually feels in production, where systems look healthy but behave badly, subscribe. This is a multi series episode where we'll have one system, real pressure, no shortcut. All right, let's build the system now. First, I would like to start with the architecture. Okay, and in the architecture, we will have a client. This client will talk to an API. This API is not doing the work. It will push a job to Redis, and the result, a worker a worker consumes the job, and this will go into Postgres database. This is how email system works. For example, in many companies, this is how video processing works. This is how report generation works. Almost every company has some or the other version of this, and most of them start with Docker Compose. All right, enough of talking now. Let's jump into the terminal and start creating the project. I'm in my Visual Studio Code right now. So here I created a directory called job system, and in this directory I am going to create an API directory, a worker directory, followed by I am going to create a file docker compose.yaml. Right now we have an API directory, worker directory, docker compose.yaml. No frameworks, no Kubernetes, no abstractions, just folders. This is exactly how most teams start. Now, in this docker compose.yaml file, I am going to write some code. So this is very simple code. Once again, as discussed and explained in the architecture, we have three services. One is API service. The second one is worker service, Redis image, and a database. So this file looks reasonable. I mean, this is what 90% of teams ship first. But it already contains some problems. For example, depends on does not mean ready. Also, if you see this file, there is no health awareness and there is no recovery logic, and this file will never warn you when you are making bad decisions. Okay, now let's jump into our API directory. Here I will try to create a Docker file, and in this Docker file also I'm going to write some code. Okay, so what do we have in here? This is also a very basic node image, no optimization, no multi-stage builds, exactly what most teams start with. And I will create another file in the same folder. We'll call it as package.json. And in this file, I'm going to write some code. So this is also very simple. I mean, if you see the name is, let's say, an API version we have, and we have a main index.js, which I'm going to create in a moment. And we have some dependencies. For example, Express for HTTP, Redis for the queue, and database Postgres for persistent. Nothing fancy here. I am not explaining in detail about each and every single line about Docker because we already have a 2 full hours Docker series in which I explained each and every single line command, what exactly the commands are doing. So that is the reason I'm not focusing on, explaining line by line here. If you are new to my channel and if you don't know Docker, definitely please go and watch that series so that you will know what exactly we are doing in this episode. All right. Now, I would like to create another file in the API folder. So let me create a file name called index.js. JS is nothing but JavaScript here. And in here, I'm going to write some code. This API does not do the work as discussed during the architecture. It just pushes jobs to Redis. The user gets a success response immediately. The work may or may not ever happen. If you see the job, that gap is where production failures hide. Now, I am going to create another Docker file in worker folder. So in this Docker file, once again, we are going to use similar Node.js image, and in here we are using worker.javascript. Also, in the same folder, exactly like API folder, I'm going to create package.json. I'm going to save this file. If not, we will forget and we'll see failures. I'm going to write some dependencies in package.json, same like API. We have worker name here. Dependencies, we have Redis and Postgres database. Followed by, I will create a worker.javascript file. And in this file, once again, we are going to write some code here. So if you see this code, this worker is intentionally dumb, as you can see. Okay, we will not have any kind of retries, no back off, no crash handling. If it dies at 2 a.m., nobody knows why. All right. Now we have most of the files and folder structure in place. Now let's try to run this simple command. Docker compose up hyphen build. Press enter. It is trying to build the Docker image, and also it is trying to pull images, as you can see, Redis, Postgres. Once we have this running successfully, we are going to use curl command and try to post a job. All right. First failure. So what is the failure? Here it says target worker failed to process npm install did not complete successfully. Okay, copy package.json. So looks like there is some problem with the worker. Fourth step, let me go there. Looks like copy package.json is the problem here. All right, let me scroll this down. I don't see major, let's say, error code here, but I only see some details about npm error, npm install. Most likely there is some problem with the package.json file. Okay, I forgot to save. Yeah, this happens. I know. Okay, my bad. Let me clear the screen and try to run the command once again. Docker compose up hyphen build. Press enter. Hopefully this should work now. Expecting at least. Yes, it works. I can see all the containers got created successfully. Okay, let me open another terminal here. So here I'm going to use a simple curl command, and let's try to post a job wherein I'm trying to write my email and username. Press enter. It shows status queued. Everything looks fine. Looks like the status is queued. I don't see any errors like logs, like what's going on. I don't know anything about it. This is where most teams stop thinking. Now let's look at the terminal logs where we did docker compose up, and if we scroll down, Everything looks good so far. Processing job, insert into jobs, error. Okay, error relation jobs does not exist. Interesting. If we look at the Docker ps command, I see our API container is running, database is running, and also Redis is running. But the write fails somehow because there is no jobs table. And if you see our docker compose.yaml file, it did not warn us, and also it did not complain about it. This is what I mean when I say everything looks green and production is still broken. This has nothing to do with Kubernetes. This is our responsibility. So now let me real quick create a folder called DB, and in this DB I will create a file, a folder called init, and in this folder I will create a file name create jobs table dot SQL. And in this file, we are going to add a simple table name jobs. ID would be, let's say, serial primary key data JSON created by timestamp and default now. This is boring, and that's exactly why it matters. Production failures usually come from boring things we assume. Now, let's jump to our docker compose.yaml file. In here, I am going to add volumes, and also I will try to give the path. So in this case, our database directory and init folder which we created. Postgres automatically runs any SQL in this particular directory only on first startup. That detail will matter later. Now, I am going to do a control C real quick and run docker compose down hyphen v, validating docker compose. Okay, looks like validation failed for some reason. Maybe I did a mistake. Yes, this should be, let's say, in here with respect to the environment, not with respect to environment variables. Good that I got an error here. Let's do it once again. Now we were able to remove the containers successfully. Now let's do a quick start once again. So I will say docker compose up hyphen build, press enter. Once state exists, code changes don't fix it. You must explicitly reset or migrate. This catches teams off guard all the time. So now let's try to run the command once again and see what's happening now. Press enter. Now it shows queued once again. And if I go back to the terminal, it shows processing job. Type email ABC. I do not see any kind of error now. If you see create database, create table, as we passed this particular file, it works. We fix the schema. The system is working normally, but look closely. I'm still babysitting containers. Now let's stop the worker on purpose. For that, I am using Docker compose stop worker. Press enter, and if I do Docker ps, I can see API service is running, database is running, Redis is also running. But production is already broken. Docker compose is still green. API is also green. Now let's try to schedule another job. Press enter. Here it shows queued successfully. I'm going to go back to my terminal. If you see here, worker 1 exited with code 137. Jobs are piling up. In this scenario, we have only one job, but in production scenarios, you'll see multiple jobs. Nobody notices, no alerts, no restarts, no visibility. Now let's do a scaling. For that, I would say Docker compose up scale workers is equal to 3. Press enter. Now if you see, it started processing my job. User down at example.com automatically. This looks like scaling, but it's not orchestration. If one worker dies, I am the scheduler. If logs scatter, I am the observability stack. So I am back to my blackboard. Here, I would like to say Docker compose is not bad. Okay, it's honest, as you saw in this video. It runs exactly what you tell it to run. And that's the problem here. There is no self-healing, no scheduling, no health awareness. The moment this system matters, teams start duct taping scripts around it. And that's how people accidentally build Kubernetes badly. In the next episode, we are not learning Kubernetes. We are solving one pain. I don't want to babysit containers anymore. That's it. No buzzwords, no magic, just enough Kubernetes to stop lying to ourselves. See you in episode 2.